Engineers just saw something that made them call it open source Skynet. A robot walked through a room doing what looked normal, but hidden inside was a system doing something machines were never supposed to do. It was remembering everything, every person who walked by, every object it saw, every moment in time. The robot was building a memory of our world. On the surface, the demonstration looked typical. Humanoid robot walks through room, LiDAR scans environment, cameras capture visual data, depth sensors measure distances. The robot builds a map, avoids obstacles, navigates around furniture. Standard robotics procedure that has existed for years. But what happened inside the system is where everything changes. Instead of simply detecting objects and moving around them, this robot started tracking where objects are located, where people move through space, and when specific events happen. The developers described this capability as spatial agent memory. That means the robot constructs a persistent model of the world around it. Traditional robots mostly operate in the present moment. They look at sensors, react to what they see, update their navigation map, and keep moving. The context of earlier events fades away quickly. This new system works completely differently. The robot connects place, object, and time together. A person walks into the room, the robot registers where it happened. That event becomes part of the robot's internal record of the environment. The machine gradually builds something resembling a timeline of the physical world. That capability came from an open-source project called OpenClaw, which over recent months turned into one of the most talked about frameworks in the AI agent space. At first, OpenClaw became popular because it allowed large language models to actually execute tasks. Instead of responding with text only, the system could control software tools, run commands, automate workflows, and interact with external systems. Developers often describe it as giving AI systems hands, meaning the ability to perform actions rather than simply talk about them. Now those hands are moving into robotics. The demonstration used a humanoid robot equipped with LiDAR and multiple cameras. Those sensors continuously feed spatial data into the OpenClaw system. What developers added on top is something called Spatial RAG, combined with that spatial agent memory layer. Together, they create a way for robots to organize the enormous stream of data coming from the real world. And the real world produces massive amounts of data. Every second, a robot collects visual frames, depth maps, three-dimensional point clouds, movement measurements, and information about objects and surfaces. Over time, the system accumulates hundreds of hours of video and sensor readings. Turning that flood of information into something structured and meaningful is extremely difficult. The OpenClaw team approached the problem using a concept called voxelization. Imagine dividing physical space into tiny cubes like three-dimensional pixels. Each cube is called a voxel. Instead of storing the environment as simple images, the robot stores information about these spatial cubes. Each voxel carries a vector representation describing geometry and a semantic label describing what exists there. Over time, the robot builds a layered structure containing rooms, objects, surfaces, positions, and timestamps. That structure becomes the robot's spatial memory. Because the system stores both geometry and meaning, the robot can search through its own experience in multiple ways. Someone could ask the robot where a set of keys was last seen. The system searches its spatial memory for the object labeled as keys and returns the most recent location. Someone could ask who entered the house on a specific evening. The robot searches movement patterns across the recorded time period. Someone could ask which room people spend the most time in. The robot analyzes spatial activity over days or weeks. The important detail here is that the robot is not replaying video recordings like a security camera. Instead, it is querying a structured model of the world. That difference is why the demo triggered such a strong reaction online. Within hours, people were sharing the clip and debating what it means for the future of embodied AI. Some researchers called it a milestone because persistent spatial memory has been one of the missing components in robotics. Others joked that someone had basically open-sourced Skynet on GitHub. Obviously, the Skynet comparison is exaggerated. Still, the reaction reflects something real. A robot that understands the connection between space, objects, and time feels fundamentally different from one that simply reacts to sensors. Another reason the project attracted attention is its flexibility. The OpenClaw system used in the demo runs independently of specific hardware. Any machine equipped with sensors like LiDAR, stereo cameras, or RGB cameras can potentially run the same software stack. That includes humanoid robots, quadruped robots, drones, and experimental robotics platforms. Even consumer hardware can theoretically participate. A developer could integrate sensors from a smartphone and connect them to the OpenClaw pipeline. Once the system runs, the machine gains the same spatio-temporal perception capability. The architecture also avoids dependence on the typical ROS robot operating system, which many robotics projects rely on. Instead, OpenClaw communicates directly with hardware and sensor pipelines while still supporting functions such as SLAM, simultaneous localization and mapping, along with dynamic obstacle avoidance. Another experiment connected OpenClaw to a 16-joint, 3-dimensional printed robotic hand called Arrow Hand Open. Using visual feedback from a USB camera, the AI calibrated the hand and began experimenting with gestures. The system eventually produced recognizable gestures such as a fist and a peace sign while narrating its actions through Telegram messages. Developers also integrated the agent with the Nero 7-axis robotic arm. Instead of writing complex kinematics code manually, users describe the desired movement in natural language. The system generates Python control scripts automatically and sends them to the robotic arm. At a larger scale, robotics platforms are integrating OpenClaw into enterprise automation environments. The Peak Robotics SDK allows robots to connect directly to OpenClaw agents and download reusable skills. Robots can share these skills across fleets, coordinate workflows, and interact with decentralized networks. One of the most unusual aspects of this system is the ability to assign machines decentralized identities. A robot can generate a digital identifier and operate as an independent entity on blockchain networks. That identity allows the robot to hold funds, execute transactions, and participate in machine-to-machine payments. Developers sometimes refer to this emerging infrastructure as the machine economy, where robots and AI agents coordinate services autonomously. 2026 is starting to look like the moment when AI agents begin interacting directly with reality. The question is no longer whether robots can remember the world, the question is what happens when they do. If you found this video helpful, make sure to like, subscribe, and hit the notification bell so you never miss our latest AI and robotics updates. For more cutting-edge tech content, check out AI Tech Academy, where we break down the technology shaping tomorrow. Thanks for watching, and I'll see you in the next one.